Well, good morning there, students. Today what we are going to discuss is how to solve a system of equations. Sound like a robot. Obviously, I haven't had my Dunkin' Donuts coffee yet because as soon as I have my Dunkin' Donuts coffee, the attitude changes. Well, y'all, we're back here to study a little bit of this there. Never mind. Enough of the comedy. Oh, the pen's working. Okay. Enough of the comedy. And some of you thinking, that was comedy? Yeah, that was comedy, bro and sis. Alright, so let's get solving. Day 9, solving systems of equations. We're going to do it both algebraically, which by, without the graph paper and the graphing paper, and graphically. Okay there, yeah. Let's do this. Now. Let's see here. Probably the easiest way to solve these is using that substitution method. I'll just say y equals x plus 3, because what I did was I brought that x over there. Now, this is what y is equal to. Well, there's a y right there. So what I'm going to do is I'm going to take this and I'm going to substitute it into that. So now I get x squared plus my new y, which is x plus 3 equals 5. I'll bring the 5 over. I get x squared plus x minus 2 equals 0. I'll do a little simple factoring. God, I should have gone into sound effects. I'm like a freaking genius. Plus 2. Minus 1. So my two x values are x equals negative 2 and x equals positive 1. We'll box those up and we'll go on to the next problem. Huh? It's that easy. What do you mean I screwed up? What do you mean I made a classic blunder? Why are you talking smack to me, bro? And sis. Huh? I finished it. There it is. I solved the system. Oh, well, that's embarrassing. I only did half the problem. Hey, kids, common mistake is just finding the x values. Come on, guys, you got to show the y some love. You also got to find the y values. Sorry, part of the problem. Don't be lazy. All right, so we said y was equal to x plus 3. So let's plug in the 1. And we get y is equal to 1 plus 3, or y is equal to 4. Finding the y value is the easy part. And then we'll do this. We'll plug in the y equals x plus 3. We'll plug in the negative 2. Y equals negative 2 plus 3, or y equals 1. Done. Move up. Seriously? You're going to keep giving me a hard time. Oh, I have to state my answers. Jeez, forgot that too. Need more coffee. So, my answers be like, man, I can't even speak English, and I didn't know where my pen pointer is. There it is. Okay, my answers are negative 2, 1, and 1, 4. Sweet. Finally done. All right, let's move up. Seriously, you're freaking annoying me. You got a problem? Because, man, I'll fix it right now. You're telling me Good idea. I like it. All right, we'll do it. Check our answers. So let's check. Because checking would be a good idea. Thank you. Man. Got such smart kids on my YouTube channel. You guys are awesome. Let's check. So our first equation is x squared plus y equals 5. We'll plug this in. So negative 2 squared plus 1. Plug in using parentheses so you don't make dumb mistakes. Equals 5. This is 4 plus 1 equals 5. I think that checks. And then I'll do the other one. 1 squared plus 4 equals 5. That's obvious. Now let me check the other equation. Y minus x equals 3. 1 minus, should be using parentheses when I sub in, negative 2 equals 3. 1 plus 2 equals 3. That checks. And then we'll try the other one. 4 minus 1 equals 3. 4, that's 3 equals 3. All right, checks. All right, I am done. Seriously, guys, though, listening. Common mistakes, just finding the x value. That's the most common mistake. You go through all this work and you just find the x value. It's ridiculous. You have to find the x and the y value. And it's a Regents exam. It is absolutely asinine not to spend the extra 30 or 40 seconds, minute, 2 minutes, however long it takes to check your answers. Because when you're done, you come back up here and you hit the red arrow and you go, wah, and you write your little note, rocked it. All right, so we won't make that mistake again, and you won't have to annoy me anymore. Okay, it looks as if, well, I'm going to solve this one for y. I usually try to solve the linear one for y. I'm going to solve this one for y, even though it's kind of a pain in the neck. Let me write it over here. 3x minus y equals 3. I'm actually going to bring this y over here, making it positive, but then I got to bring the 3 back, making it negative. So it's going to be 3x minus 3 equals positive y. Now you can show those steps if you like, but that's it. So now what we're going to do is we're going to take this and we're going to plug this in here for y. So what I end up with is 3x minus 3 plus x squared equals 1. Since my x squared is positive, we're going to leave everything on this side of the equation. You always want your x squared to be positive, and we're going to put it first. Plus 3x minus 3, we're going to subtract 1, so I get minus 4 equals 0. The factoring is a joke. Did I pick all easy equations? These are all easy. X plus 4 minus 1, x equals negative 4, x equals positive 1. Remember, you got that annoying person that's going to tell you not to stop, so I'm going to do it right here. Y is equal to 3x minus 3. Plug it in. So I get y is equal to 3 times negative 4. That's a 4. Remember, that's a problem though. You don't want to make, like I'm having a hard time because electronically it always seems to drag over there. But you need to make sure you're neat. Pick up your pen. Be neat. If you don't know what this is, type it into your calculator. This is negative 12 minus 3. That's negative 15. Yeah, that's weird. So I got the point, negative 4, negative 15. I've got one of my answers right now. It is so weird, I'm absolutely going to check it. Y equals 3x minus 3. Y equals 3 times 1 minus 3. That's 3 minus 3, which is 0. So this answer is 1, 0. So now I'll throw my check down, right? Check it. Hopefully my big fat head's not in the way over here. Ooh, that could have been a problem in the last problem. We're going to check it in this equation. Y plus x squared equals 1. I'll just check it in one equation. You should check it in both equations. I am being a little bit lazy, but I'm not taking a Regents exam, and I'm pretty sure I didn't make a mistake. I hope I didn't. Let's try this weird one. Negative 15 plus negative 4 squared equals 1. This is negative 15, should have put that in parentheses, plus 16 equals 1. Negative 15 plus 16 is in fact 1. 1 equals 1. Check it in the other equation. 3 times x, which is 3 times negative 4. Look at that. Every time I make a 4. Minus negative 15. Notice I use parentheses. Equals 3. That's a 4. So this is negative 12 plus 15 equals 3. 3 equals 3. And you would check in the other one. But my big head's in the way. I don't want to do that. So let's keep going. Oh, this one's easy. You already have both of them set equal to y. That makes it even easier. I'm just going to take this. Plug it in for that. So I get 2x plus 5 equals x squared plus 2x plus 1. Bring that out. Did I ever? That's really weird. All right. So, wonder why I didn't do that. So we'll subtract 2x, subtract 5. We get 0 equals x squared. Oh, maybe I should show this step because you're going to get confused. We're going to subtract 2x and we're going to subtract 5. So I get x0 is equal to x squared minus 4. Ooh, well, that factoring is pretty easy. X plus 2, x minus 2. My two answers are x equals negative 2 and x equals positive 2. All right, got to find my y values. Y is equal to 2 times negative 2 plus 5. So y is equal to negative 4 plus 5, which is equal to y is equal to 1. So y is equal to 1. So my point is negative 2, 1. And we'll check the other one. Y is equal to 2x plus 5. We'll plug in the 2. Y is equal to 2 times 2 plus 5. I get y is equal to 9. So my point here is 2, 9. Let me check it. The equation I'm going to check it in is y equals x squared plus 2x plus 1. So let's go. 9 is equal to 2 squared plus 2 times 2 plus 1. 9 is equal to 4 plus 4 plus 1. That's easy. That's checks. Now we'll do the other one. Y is equal to x squared plus 2x plus 1. What's the other one? 1 is equal to negative 2 squared plus 2 times negative 2 plus 1. 1 is equal to 4 minus 4 plus 1. Checks. All right, there we go. All done. All right. I'm going to solve one more system algebraically. Let's see. This right here is what y is equal to. But if you plug it in here, you're going to have to be really, really, really careful because it's got a negative on it. That bothers me. I mean, it's not bad. I could do this. 3x minus, but you'd have to sub it in using parentheses equals 19. And there's a good chance you're probably going to make a mistake. You're going to sub this in here, but you're probably going to make a mistake with it, with a sign or something like that. That's dangerous. So I'm just going to start out by solving this one for y. I'm going to move this over here, and I'm going to move this back over here. So I end up with y, you won't like that. I end up with 3x minus 19 equals y. All right. So now I know that this is y, and I can take it and plug it in right there for that y. I don't know why I use that big one. So I end up with 3x minus 19 equals x squared minus 3x minus 10. The x squared is positive, so everything's coming to the right side. X squared minus 6x plus 9. Oh, the factoring here is easy. Oh, I know I did this one. It's x minus 3, x minus 3. So I only really get one answer, 3. Okay, so there's only one solution. These things only hit each other one time, which is really weird for a parabola and a line. That's really rather odd. Oh, I know why. So let's plug in. So I got y equals 3x minus 19. We'll plug the 3 in. Y equals 3 times 3 minus 19. You get y equals 9 minus 19. So y equals negative 10. So my point of intersection is 3, negative 10. Let me check that in that other equation. That equation, y equals x squared. I don't know why that stuff's disappearing. Why are you disappearing? X squared minus 3x. All right, let's change pens. Maybe. I don't know what's going on. Minus 10. Hold on. Oh. I'll be back. Well, you probably noticed I was having video issues. I don't know what was wrong with that. And if I wait too long, sometimes I don't know what this recorder. Sometimes the voice gets out of sync with the audio, which is sort of annoying. I'm also having a hard time. Let's see. Minus 3x plus 10. Hopefully, now it's working. Okay, so we're going to plug this in. So negative 10 is equal to 3 squared minus 3 times 3. Oh, it should be minus 10, not plus 10. I was just about to think that's not going to work. Minus 10. Minus 10. Because this is negative 10 equals 9 minus 9 minus 10. These cancel. I get it works out. So it checks. I like to, however, always go over and I thought I had my calculator up. I don't know what happened to it. How many days I got? I got 15 days left. Next. It's going to barely be enough. Barely. Not going to be enough. Barely going to be enough. I like to look at things graphically anyway. Even though they say you have to do it algebraically, there's no reason why you can't look at it graphically. My two equations were y equals x squared minus 3x. So x squared minus 3x minus 10. It's going to be way off, so you may want to just grab it and go like that with it a little bit. And then the other one is going to be y equals 3x minus 19. We'll hit tab. 3x minus 19 and hit enter. And you'll see right there is the only point of intersection. Now I can also use my menu here. I can just check it. Menu, analyze the graph. Yes, I say analyze just for fun. Intersection. You click here. Oops, I don't know why I did that. With this calculator, you get a dotted line. You got to get to the left side. You got to get to the right side. And then it will tell you that the point of intersection is 3, negative 10. It's another way to check your answer. Let me show you on the other ones real quick how to check it. We'll check this one right here. X squared plus 2x plus 1. So we'll go into graphic mode. X squared plus 2x plus 1. That ought to probably graph nicely. And then 2x plus 5. Tab 2x plus 5. Enter. And you can't see both, but if you drag it here, and then we go menu, analyze the graph, intersection, click to the left side, click to the right side. You can only do one at a time, so there's one of our answers. Negative 2, 1. Yes, graphically is a lot faster. Menu, analyze the graph, analyze the graph, intersection, click, click, and you get 2, 9. And those are my answers, and it's a great check. It's a simple check. As a matter of fact, it's probably easier than doing this, you know. This is a pain in the neck. It's probably easier just to do it graphically to make sure that you have it done correctly. But you got to be careful. And if you're asked to graph it algebraically, if you're asked to graph these, I didn't do graphing a parabola, but you'll see that when we do graphing, you have to do a little bit of work. Like what I have here is I have a parabola, I have a line, and I have an absolute values. And I'm going to graph it over here, but I have to show some kind of work. So first thing I'm going to do is solve this for y. I get y equals x minus 1. My slope is 1, and my y-intercept is 0, negative 1. So I'm going to graph that, 0, negative 1, slope of 1, I go up 1. If you are really crappy at graphing, you just don't get it, you've never have getting it, I don't know why you're in trig, but that's okay. You probably got through by other things. You should graph a straight line here. You should use a ruler. And that's that one. We'll change over here. We'll graph this one. We get y equals negative absolute value of x plus 4 minus 1. You could at this time, if you understand this, tell me the vertex is negative 4, negative 1. It's going down with a slope of 1 and graph it. But easier than that, just come over to your calculator. And you're going to type in negative absolute value bars are found right here. Absolute value bars, enter. It does not like when I click on that menu. I don't know what it is about that menu. Absolute value bars, x plus 4 minus 1. Couldn't remember. Oops. Got to get out of the absolute value bars. That's one of the other mistakes made commonly. Minus 1. Make sure it looks exactly like what you have. Yeah. Enter. And then I'm going to go to table. Control T. It's going to go over to the table. And I'm going to copy down everything that's not bigger than a 10. This is annoying. Negative 10, negative 7. So it's going to be a lot of points. X, Y, negative 10, negative 7, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4. That's actually going to be where the vertex is. Negative 3, negative 2, negative 1, 0, 1, 2, 3. I think that's about all we're going to get. It's negative 7, negative 6, negative 5, negative 4. So negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. See, there's my vertex. And I could have gotten it by just looking here. Negative 4, negative 1. If you understand that, remember that. 0, 1, 2, 3, 4, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. That's probably plenty. So it's negative 4, negative 1. And we're just coming down. So this one's only going to have one solution. Got to be accurate in your graphing. You get off like I just got off on that line right there, you could be in trouble. So there's your one point of intersection. It looks like our one solution is negative 2, negative 3. But I'm going to graph this line anyway. This line x minus 1. Hit Control T to get rid of that table again, and I'll just hit tab. Move this up a little bit. I'll hit tab, and I'll do, what was it? X minus 1. X, it doesn't like that. Tab, X minus 1, hit enter, and you'll notice there's only one point of intersection. Menu, analyze the graph, intersection, click, click, enter. There it is. Negative 2, negative 3. All right, let's do another one. So let's graph the line first. So this is y equals negative 2x plus 6. My slope is negative 2 over 1, and my y-intercept is 6. 1, 2, 3, 4, 5, 6. Again, if you're not good at graphing, you can always come over here. Even if you're not really sure, is it going up, is it going down? You go negative 2x plus 6. Hit the enter button. Oh, yeah, that's right. It's coming down. Oh, yeah, we're going down 1 to the right 2. If you don't like that, go to the table. Look at the table. Copy over the table. Graphing lines with this is sort of a pain. Your line has to have a straight line. I can't do that. There's just no way to draw a straight line with this. So this one right here, you got y equals absolute value. I should use a different color. Y equals the absolute value of x minus 6 plus 1. So we go again, my vertex is 6, 1. So I could go 1, 2, 3, 4, 5, 6, 1. There's my vertex. And I'm going up 1 over 1. There it looks like a point of intersection. Up 1 over 1. Looks like we're going to only have one again. That's really weird. I picked two of them that only had one solution. But you should probably come over the table and copy it down. I'm not going to because, kind of waste time. Looks like my answer is 0, 6. Let's graph this sucker. Tab, the tab button. Absolute value of x minus 6. X minus 6 plus 1. Enter. Oops, can't even see my point of intersection. Uh-oh. Menu, analyze the graph, intersection, click, click. I got a problem. I got negative 1/8. I did not mean to make that mistake. Let's see who's right. Negative 2x plus 6, negative 2x plus 6, x minus 6 plus 1, minus 6 plus 1. I'm going to guess my graph is off. 1, 2, 3, 4, 5, 6. Down 2 over 1. 1, 2, 3, 4, 5. Ah, there's my mistake right there. One, 2, 3, 4, 5, 6, 1. Now I go up 1 over 1. You're going to tell me checking your answer is not important? Psh, look at that right there. I just made that mistake. Would have lost all credit. If you don't show enough work, by the way, and those should be straight lines, I would definitely write the list down. It can't hurt to always go to your table, copy the table down, just plot the points, be methodical, go through it slowly. Psh, that's it. All right, so what I'm going to be doing is going back in class and doing some more logarithms because clearly this is not a long enough review session. I hope you all enjoyed your time with me. Goodbye.